everyone, welcome back to the Logic Lab. In today's video, we'll discuss something about an algorithm. Okay, first we'll see what is an algorithm. Okay, and then we'll see why do we need this algorithm, and then we'll see how do we write an algorithm. Okay, now before going to this concept, let's just quickly discuss about a simple example which is very close to our daily life. Okay, because in our daily life we almost follow this algorithm concept all the time. Okay, that's why I'm just taking our daily life example. Suppose I just want to make a tea. Okay, how do you make it? You will just follow some steps, right? In the first step, you'll simply take pan and water, right? And then, as second step, you will boil the water. In the third step, you'll be adding tea leaves, right? Tea leaves and then sugar to the boiled water. In the fourth step, you will add some milk. After boiling it for some time, finally, you can just simply serve the tea. These are the steps that you will follow to make tea, right? Now, I just want to define an algorithm using this example. I'll give you the definition of algorithm now. An algorithm is a step by step procedure to be followed in order to perform a task. Okay, an algorithm is a step by step procedure to accomplish a particular task. Okay, now you know what is an algorithm. Next, we'll see why do we need this algorithm. Suppose I just want to construct a house. I don't start constructing the house as soon as I plan it, right? Before constructing the house, you will have something called blueprint in your hand, right? What is the purpose of that blueprint? See, instead of constructing the house directly and having mistakes, it's a huge mistake, right? You just can't simply take it back. So, to avoid such kind of mistakes, first you will plan properly on a paper, which is called blueprint. In the same way, this algorithm is also like a blueprint. First, you have a problem to be solved. Okay, you need to write a program. So what do you do? First, you will break that problem into number of steps and then you will write it as an algorithm. Okay? So you will just write algorithm as a step by step procedure. You will have a proper plan. Okay? So what is the purpose of first purpose of writing an algorithm? So to simply avoid mistakes, right? To avoid mistakes, first we will simply plan the algorithm. Okay, and then second purpose is you will have proper documentation of the program. Okay, so what is the purpose of using this documentation? Okay, see, if you want to solve a problem, you will just think of this logic. We'll see what is logic in the same video. We'll just think of this logic only once and you will just simply document it. What is the purpose of this documentation? Once you have documentation in your hand, you can just implement that particular algorithm into any programming language. Okay, you will just plan it once and implement it in many languages. So that is the purpose of writing documentation. Now we know why do we need an algorithm. Okay, what is the last thing? How do we write an algorithm? Okay, we'll see how to write an algorithm first. Now, let's if I ask you to solve a problem, no, if I ask you to write a program, you don't have to start the program right away. First, you need to plan it. You have, in the traditional process of writing a program, we will first write an algorithm. We'll have some flowcharts. We'll see flowcharts in some video. In the further videos, we'll just have algorithms and then flowcharts. After having proper documentation, we'll start writing the program in the required language. Okay, let's just take our traditional example, which is adding two numbers. Okay, see, suppose here I just want to add two numbers. Let's write an algorithm for this first. Okay, the first and the basic step of writing an algorithm is, see, you always start an algorithm with step one, which is very easy step. You can simply say start. That's it. We are done with step one. And then it's not that you have to follow a particular syntax to write an algorithm. Okay, you can just follow, it is simple English language. Okay, it's in simple English language and you can follow any syntax because you are not implementing this in a programming language, you are just planning it, right? So now you need to, step 2 is to declare three variables. Okay, A, B, C. I'll just deeply explain this declaration of variable when we come to the actual programming language. Okay, let's not bother about that step now. Now, next step is, through the keyboard you need to read the values of A and B, right? First, in order to add A and B, you need to accept the values, right? You need to have values into A and B. Next step is to add the numbers A and B and keep the result in a variable called C. This is step 4. And then step 5 will simply print the output on the monitor, which is C. And then last step is simply stop for, see, step 1 and 6 are very easy, right? Just start and stop. This is how we write an algorithm. Okay, we have just broken the problem into different steps, and if you see this, no, I just we can just remind one topic which we discussed already. Suppose, see, here you're just reading the input, right? Input, and then you're just doing processing. Input, process, and then output, right? See, this is the concept that we discussed already. Input, process, it's a sequence, right? When we follow this sequence and when we break the problem into number of steps, we can just easily write any program. Okay. Now, so this is how we write algorithm. Okay. Now, I just want to discuss one more topic while discussing this algorithm itself. See, suppose let's just have one more simple problem. Suppose here I do have two variables A2 and then B3, and I do have another empty variable. My program is to swap these values. You know, you might have heard of swapping, right? Swapping is interchanging the values. That means I just want to swap, place the value 2 into B and then 3 into the variable A. Okay, this is swapping. So when I print the variables, I should get the value of A as 3 and value of B as 2. This is nothing but swapping. Okay, so before discussing this, I just want to tell you what is logic actually. Okay, I paused the video and I drew this just to not waste time. Okay, now let's see what is logic. Okay, suppose I have two buckets, say bucket A and then bucket B. In bucket A, I do have red colored water, and then in bucket B, I do have blue colored water. Now I just want to swap these. I just want to pour bucket B water, I mean blue water into bucket A and then red water into bucket B. What you are given an empty bucket already. Okay, what do you do? Just pause this video and then think of the logic. Okay? What do? Simply first, you'll just pour the water, red color water into this C, right? You will pour the red color water into C. Now, this C will have red color water and this will have empty, right? This A will have empty. Now, what will you do? You'll just simply pour this blue color water into this bucket A, right? Now, what do we have in bucket A? Yes, now this is empty. Bucket B is empty, right? Bucket B is empty. Now it's white in color. Now what do? Simply you will pour bucket water which is in C into bucket B. So what do we have in bucket B now? You will have red color. See, swapped. Now it will have empty, right? Now C, bucket C has no water. Okay, now you swapped. Okay, red to blue, you swapped. How do you put that in the form of statements? First, C is an empty variable, right? Okay, into the C, you're pouring the water in bucket A. Now bucket A is empty. What do now? In the bucket A, you will pour the water which is in B, right? And then into the bucket B, you will pour the water which is in C. See how simple the logic is. Now we'll see what is this logic actually. Logic is nothing but how do you know what to do here actually with your common sense, right? It's just common sense, right? Putting your common sense into the form of statements. Okay, putting your common sense in the form of statements is called logic. Okay, it's not a rocket science. Once you get that logic, okay, anyone can write the program, but it's just the difference. One person can write the program in one day, one person may take 2 days, one person may take 1 week. Okay, it's just that how sharply you're thinking. Okay, once you get the logic, okay, seriously believe me, if you get the logic of at least one tough program, you can just write it for any number of programs. Okay, once you get that logic, no, you can write the program easily. Now, can we just write an algorithm for this swapping? Okay, step one, simply, as you know, start, right? And then what is step two? You will have to, I told you, we will have to discuss about this declaration later. I have three variables, okay, A, B, C. Now, what is step three? I think you can write it now easily. Read the values, okay, read the values A, comma, B. Now, step four, in the step four, so this is input, right? Sequence we are following. Step in the step four, you can just have processing. What is the processing here? We already got the logic. C equal to A equal to B, and then B equal to C. And then what is step five? In step five, you can just bring the values of A comma B. Okay, and then finally step 6 is to stop it. Got it? Now you can just see by just Dryden, we call it as Dryden method. Okay, by simply just like the bucket of water, you can just compare these variables. Initially, what do you have? A is equal to 2, B is equal to 3. And into this C, you're just saving the variable 2. Now C has 2, right? And then to the A, you're copying B. A will have 3. And then to the B, you're copying again C. Now A has 3, B has 2. Okay, values got swapped, right? This is how we write an algorithm. Okay, this is about what is an algorithm, why do we need an algorithm, and how do we write an algorithm. And finally, we also discussed about what is a logic. Okay, hope you like this concept. Okay, thank you so much for watching this video.